Okay, Rough as Guts Videos presents Week 7 Video 5, more on functions. So, as this slide says, a few little extra things about functions. You've been using them all course so far, but here's a few extra things to give you more flexibility with some more challenging programming examples. In particular, we're going to talk about default parameters, named parameters, and how you can write functions that have variable number of parameters. So, I don't know whether you've noticed, if you've been browsing through the documentation, things like the find method of a string, for example. If you were to look at that, let's have a string s as this is a string, and let's suppose we wanted to find the occurrence of an s in that. We can go s.find the character s inside that, and we find it at position 3. What you probably didn't know was that we can actually start searching somewhere else. Let's start searching from position 3 onwards. 0, 1, 2, 3, no, I mean position 4 onwards. Then we find it at position 6. There's position 4, 5 and 6. We can start at position 7 onwards and find the third occurrence, and so on. So the find function, or method actually, of the string is kind of flexible because it can take just one parameter, which is the character to look for or the string to look for, or it can take a second parameter, which is the starting position for the search. And there's a few other examples of that sort. So how do we do that? Well, it turns out that we can solve this or write code ourselves this way by using what are called default parameters. So just to on the fly generate the example on the left hand side, let's write our own function which finds the first occurrence of a particular item in a particular list of data, and we give it a parameter start index which we say is equal to 0. So the key thing we've introduced here is this idea that we can give a default value to a parameter. Notice that we do not put spaces around the equals in this case, as we do in an assignment statement. This is called an initializer. So I'm going to say it finds the first occurrence of item in data starting at index start index. And it's perfectly straightforward. I should also have said what happens if we don't find it, which I shall now say, return -1 if not found. So we say that the index is -1, and we do something like for I in range start index up to the length of the data. So we're going to search the entire range of data. If the data item at that position is equal to the item we're looking for, and the start and the index is equal to -1, meaning we haven't found it yet, then we say the index is equal to I. And at the end of that, we return the index. So let's have a couple of tests on this. Let's find the first occurrence of the value 10 in the list 20, 10, -3, 10, 5. And let's write that again, but this time let's start at position 0, 1, 2, which is the -3 item. So there's the 0, 1, 2. So we start searching in this position. Let's see what we get, except I wanted to print that, didn't I? Print the first occurrence and print again. Let's see what we get. Hopefully, if I haven't goofed, we get 1 and 3. So when we first call it, in this example here, we find it at position 0, 1, which is fine. When in the second call, because we start at position 2, 0, 1, 2, we find it at position 3. So that works. So simple idea, we can provide an initializer for one or more parameters. Notice that it says defaults may be specified for any trailing set of parameters. that is the same as saying parameters without defaults must come first. So I can't write stuff like this, that by default we'll search for the number 10 in data. That now becomes very confusing if you do that, because well, there's an example on the next page. Find first, if we were allowed to write something like the start index equals 0 as the second parameter, then you'd have confusing things like find first occurrence of 1 in this list, find first occurrence of 1 in this list, what? Find the first, very confusing. As an aside, you cannot use a value here, which, for example, you cannot write end index equals the length of the data, because it has to be able to work out the default values of the parameters when you execute that definition. So that's what it says here. Default values are calculated at time of function definition, that is, when the def statement is executed. And it doesn't know what the parameter data is going to be then. So I can't do that. And that's what that slide gives as well, that it's illegal to do things like that. So that's first example of something we can do that's kind of new to you, and I'm going to take that out because it's wrong and confusing. That's give default values for parameters. Another thing you may have noticed is that there exist functions like max, where I can say what's the max of 10, 20, minus 5 and 11, and it tells me that the maximum value is 20, and I can have variable numbers of parameters. How can I do that? Well, turns out I can write my own function max. Let's write one of these. I can have a function def my max. It's called an our max over there. Let's be variable my max the first, and I can say star rest. And just to explain what's happening for a start, I'm going to print first and rest. Notice I printed rest, not star rest. So that star is just looking plain weird at present. We'll come to that in a minute. I'm going to copy out those, just delete them, why not? I'm going to print my max of 10, 20, 30, 40, minus 6. What do I print? When I call the function, it prints two values, 10 and a tuple, 20, 30, 40, minus 6. So what that star has done here, kind of clever, it's taken all the rest of the parameters, it's matched the first with 10, and it's taken the rest and said, well, he's used this funny notation star. That means pack up all the rest of the parameters into the rest value. So now that allows me to write something like this. Biggest is equal to first, and then I can say for value in rest, if value greater than biggest, then the biggest is equal to the value, and at the end of that I'll return the biggest. So now with that variation, see what we've done? We've initialized it to the first one, we've gone through all the rest of them to see if they're bigger, and if they are, we record the biggest. So now when I run the code like that, it works for any number of arguments. So I can stick in as many as I like in here, and it still works. Cunning, huh? There's various functions that you've used in the libraries that do this. So the print function can take any number of arguments, and the format function, of course, can take any number of arguments. What else have we got on this section of the notes? There's another cunning thing you didn't know about, and that is that, let's go back to, let's write an easier example. Let's write a function divide top by bottom, and all it does is prints the top divided by the bottom. So I can now call divide 10 by 20, and hopefully you're not too surprised to discover that it prints a half. But I can, funnily enough, write a different thing altogether. I can divide bottom equals 20 by top equals 10. I've put them in the wrong order, but I've given them names, and now it still prints 0.5. And if I change them 10 to like this one, divides the top 20 by the bottom 10, and it comes out to 2. And notice now it doesn't matter what order I put them in. I can put top equals 20 here and bottom equals 10. Do it that way round, and it still prints 2. So if I can't remember the order of the parameters, but I can remember what they were called, then I can put them in any order and specify what the values of each one, the value of what the value of each one is. Right. So there's another example of keyword arguments, a rather more elaborate one in the lecture notes, just here, where we have a function that prints out a description of some creature with a name, a species, an age, and a weight. And we've got two calls to this. The first one in which we list the parameters in order, the normal way we've been teaching it to call functions, and another version where we list them in any order we like. Notice that you can't mix these. If you're going to start using keyword approaches, as it's called, keyword arguments, then you can't suddenly decide to stick in a positional parameter. It just doesn't make sense. And when might you use these? Well, it turns out that they're mostly useful in cases where you have functions with a large number of parameters. So here's an example where we have a way of ordering a Honda Civic, for example, and you can, all these different parameters, what color it is, what CC rating, what form it is it hatchback or a wagon, whatever else, what transmission, tow bar is installed or not, what audio device it has, CD, maybe, drive, right hand, left hand, whatever. And you don't necessarily want to have to specify them all. So you can call that function with just specifying the parameters that are different from the defaults. So you have to, I'm going to order a Honda Civic. I'm happy with all the defaults except I do want it to have a tow bar. Or I want a tow bar, but I also want it to be red and I want a 2000 cc rating version. So that's kind of nice, just a different way of dealing with rather complex functions. Those of you who are going on to use MATLAB maybe, Matplotlib, sorry, the plot function in Matplotlib has a huge number of options to specify what color the lines should be, whether they're dotted or dashed, or what the rounding is on all the different segments, what axes you want. Do you want a grid inside the axes, and a whole heap of different options, most of which you just accept the defaults. So you don't want to have to list them all the time. So that's nice for complex contexts. And we finish with a quiz. So here's some things for you to work through. I'm not going to do these in the video, of course. I'd just like you to work through, see if you can predict at each case what will happen. Got your computer with you. Define a function foo, which has a default parameter x, which is default value of 42. And you've got to decide whether each of those expressions typed into the shell is legitimate. And if so, what does it produce? Or whether it's illegal, and if so, why is it illegal? And there's another slide of the same stuff. Thank you. That's all for this video.